Good evening. We are going to concentrate now upon the red planet Mars, now brilliant in the evening sky. With me, Paul Abel, Pete Lawrence.
Right.
The first thing to do is to find it. Pete.
Well, Mars is quite easy to find at the moment, Patrick. It's bright and distinctly reddish in colour. And the way to find it is to locate that very familiar signpost, which is known as the Great Bear or the Plough, or I call it the Saucepan. Well, if you take the two stars closest to the handle, extend them down, you come to a brightish star, which is Regulus in Leo the Lion. You know you've got Regulus because there's a backward question mark above it. Well, Mars is easy to find from there because it's off to the right and it's the brightest thing you can see in that region.
Now I think a few basic facts. First of all, Mars is a planet smaller than the Earth. I've got two globes here to show that. There's
there we
Mars,
go, I'll give you Mars.
Thank you, Pete.
and there's
And
the
I'll
Earth.
be the Earth.
As you can see, Mars is much the smaller of the two. But that means it hasn't got so much gravity. It doesn't pull so strongly. It's got less air. And also, because it's further from the Sun, just over 141 million miles, it's colder than the Earth. So we certainly couldn't live there unaided. Nevertheless, Mars has always been in the world regarded as the possible abode of some kind of life, and we're still not sure. So there's Mars. Now, having found it, what about using a telescope? You don't need a large telescope. Even with a small one, such as my lovely 3-inch refractor, you can pick up detail. Here's the drawing I made with it.
Yes, I found this in your slide room. This dates back to 1952. And with your 3-inch refractor, you've got some evening clouds on the terminator here, and of course the prominent Syrtis Major marking. And a bit later on, with your 5-inch Cooke refractor, here's the drawings you made of the Solis Lacus region on Mars.
Now, may I look at one of your drawings, Paul?
You can, certainly. There we go. This is one I made fairly recently, on the 27th of January, and the Acidalium region is quite prominent, as is the North Polar Cap, which is quite bright at the moment.
So let's make out just what these features are. First of all, the polar cap. That looks like ice or snow or frost. It's exactly what it is. It's mainly water ice. You expect that. Here we have dark markings, once thought to be seas, but you can't have seas on Mars. There's not enough air. So we now know they're not even vegetation. And that's quite a new discovery, isn't it?
It is, yes, absolutely. The complexity of this region is quite fantastic as well, and you can see when you look at it.
It really comes out well in the eyepiece, but you really need a good scene to get those fine, tantalising
But
details.
these fine lines which you can see there, you can actually understand why people probably thought there was actually civilization there building something on the surface of Mars.
And of course they change over time.
They do.
Because of the weather, the dust, the glows.
We've basically got the sort of lighter regions are the sands of Mars, if you like, the desert areas, and they shift with time, don't they, as the wind blows.
And of course the seasons are long. Mars goes around the Sun in 687 Earth days, a long year, but its day is half an hour longer than ours, so not all that different.
And that's really quite frustrating as an observer of
Yes.
Mars, because when you look at it and then you go out the next day and see it again, you see a little bit round, and then you get a repeat of what you saw the previous
Takes
night.
ages to build up. This is about 3 or 4 weeks before you can see the whole Martian surface.
That's right,
Isn't
yeah.
it?
So basically, the polar cap is icy. The dark areas are places where the red dusty stuff has been blown away.
Yes.
And those red areas are deserts, but of course they're not like our deserts. No palm trees and camels there.
Definitely not.
They are cold.
They are very cold. And in fact, one of the nice things I think you can see through a telescope, and it really emphasises just what a dynamic, fascinating world Mars is when you get these morning and evening clouds over the desert.
They're beautiful, aren't
and then
they?
when
Really
they collect
good, yeah.
around the volcanoes in the Tharsis region, you get those weird W-shaped clouds. It really brings it home to you that this is another world in space.
I completely agree,
It's
yeah.
a fantastic sight.
Well, a lot of people have been drawing Mars, haven't they?
They have. It's not just me anymore. Loads of people are doing it. This is quite a nice one, I thought.
It
This
is.
was sent in by David Hartley. This shows the Syrtis Major, and we have the North Polar Cap and the Lowell Band. We have another one as well.
We do. There we go. That's a beautiful image. It almost looks like it's been imaged, actually, photographed. It's very well
Much
rendered.
better than that, Peter.
I've got some images here which have been taken by amateurs through slightly larger telescopes,
Yes.
sort of ranging from about 10 inches up to
Yes.
14 inches. It's rather unfortunate, but amateurs tend to call this the boring side of Mars, because it's just...
Who took that one?
This is Alan Friedman, and
Oh, yeah.
I really do like this, because it's a beautifully rendered image.
Look at the detail in the polar cap, look. You can see, because it's currently spring in the north.
Well, the polar cap waxes and wanes with the Martian seasons, just as ours does.
Absolutely.
and I think it's
does.
starting to break up. Look at the fine structure
You
he's
can
got
see it
there.
there.
That's beautiful.
You've also got some lovely clouds, of
Yeah.
course, visible there as well.
Wonderful stuff.
But I've got a nice little detailed image here from Peter Edwards,
Oh, that's very
which
good.
is gorgeous, and it shows the region which is actually in your drawing.
Yes,
Paul.
they're quite comparable, aren't they?
Well, we're looking at Mars for over 60 million miles, always from over 30 million. What we need are rocket probes, and they've been sent there. Some have landed, some have orbited, and we had those two splendid rovers, Spirit and Opportunity, crawling around Mars and taking back the most amazing data. Spirit's terribly is now stuck, but they've done their work. And Chris, been to America, talking to the key man of the whole program, Professor Steve Squires. And so now, over to America.
A few weeks ago, I visited snowy upstate New York, where Cornell University is home to a group of scientists who've been on an incredible journey. In January 2004, two remarkable rovers touched down on the surface of Mars. Spirit and Opportunity were only supposed to last for 90 days, but 6 years later, they're still going strong. The rovers are essentially robotic geologists that can move around, take pictures, and analyse rocks to determine their composition, and so build up a picture of the Martian landscape. Spirit landed in a large crater called Gusev, left over from a long-ago meteorite impact. On the other side of the planet, its sister, Opportunity, landed on the plains of Meridiani. Both sites were selected as they looked, at least from orbit, to be likely places to find evidence that Mars was once a warm, wet world. Spirit was the first to land, but quickly discovered that the surrounding rocks were volcanic and had little to say about water. So the rover headed off to the more promising-looking nearby hills. Opportunity, though, hit the jackpot. Right in front of it was an exposed rock face, bedrock, that clearly showed evidence of water. Critically, this is evidence that Meridiani was once a lake or a sea of liquid water, right here on the red planet's surface. Meanwhile, Spirit had heroically climbed up Husband Hill, finding evidence that here, too, water was once common. Opportunity had been travelling too, first reaching nearby Endurance crater, and then heading off across the sand dunes to a much bigger crater, Victoria. Steve Squires has dedicated his career to build spacecraft to land on Mars, and he's led his team on this epic 6-year journey. We started talking where we'd left off on his last Sky at Night appearance, with Opportunity's arrival at Victoria Crater.
Victoria is about 800 meters in diameter, and about 70 meters deep. It's got cliffs on the crater walls that are vertical in places and can be as high as 6, 7, 8 meters. So it's a dangerous place. I mean, it's the kind of place where if we make a mistake, our little rover could fall off a cliff and die. So when we were operating along the rim of Victoria, we had to do so very, very carefully.
Why is Victoria Crater special?
Well, Victoria was the deepest hole in the ground that we had access to. You know, we didn't bring dynamite, we didn't bring a drill rig, we have no way of looking below the surface other than what, you know, looking at the holes that nature has dug for us. And at the Opportunity site, getting below the surface is particularly important because the rocks there are sedimentary rocks and they're flat-lying, they're layered, okay? And the terrain is very flat, and so if you're driving along the surface, you're basically just seeing the same layer over and over, and you don't know what lies beneath.
And that means you're looking at the same time in Mars history.
You're looking at the same time in Martian history, you're looking at a record of the same environmental conditions in Martian history. You're basically doing the same thing over and over. If you can get below the surface, you go back in time. And Victoria is this huge, big hole in the ground.
You did a very long exploration of the rim.
Yeah, we spent nearly a year working our way along the rim. So what you have are these kind of alcoves, and they're just tens of meters away is a cliff.
And so you can do lots of your science.
Exactly. There's like 6 meters of vertical rock there to be imaged. But this is the tricky part. To get the shot you want, to get the image that you want, you need to drive right to the edge. So there was this incredibly intense year where you've got the rover drivers, the engineers, whose job it is first and foremost to protect the vehicle at all costs. And then you get the scientists saying, just go a little closer to the edge. Just go a little closer to the edge, you know. And there were times where literally we practically had the front wheels hanging over the edge of a cliff to get the shot that we wanted.
Were you always going to go inside the crater? I remember a lot of debate at the time, because what if you got stuck in there? That's it.
Yeah, we went...